July 9th, 1958, Lituya Bay, Alaska. 3 fishing boats are just chilling for the night. At 10:15 p.m., the entire world starts to shake. A massive 7.8 earthquake rips through a fault line right at the head of the bay. But the shaking wasn't the real problem. The real terror was what happened next. High above the water, the quake literally shook an entire mountainside loose. We're talking 90 million tons of rock and ice. That mass plunged almost 3,000 feet straight into the water. The result was instant and insane. It created a wave so big it's hard to even believe. A wall of water slammed into the opposite shore, wiping the land completely clean of trees and soil up to 1,720 feet high. That is taller than the Empire State Building. It's the tallest tsunami wave ever recorded in history. The wave, still huge, ripped down the 7-mile-long bay at over 100 miles an hour. It actually picked up one of the fishing boats and carried it over the trees and out to sea. Amazingly, the 2 people on board actually survived. The other boats weren't so lucky. For over 60 years, the scar left on that mountain has been a terrifying reminder of what nature can do. But what if that wasn't just a freak event? What if, right now, another Alaskan fjord has a hidden clock, and it's ticking down to an even bigger disaster? A landslide ready to unleash a 100-foot tsunami, not in a remote bay, but aimed directly at towns and a major shipping port. The science is clear. It's just a question of when. Welcome to Prince William Sound, Alaska. It's a stunning landscape carved by glaciers, with insanely steep mountains dropping right into the ocean. Tourists have been coming here for decades to see the awesome Berry Glacier. But as the planet has warmed up, the glacier has been melting and backing away up its valley. And as it pulled back, it revealed a terrifying secret. A massive, unstable slab of rock, which used to be held up by the glacier's weight, is now totally exposed and unsupported. This mountainside is soaked with meltwater and getting weaker by the day, and it's slowly sliding toward the sea. People have known about this landslide for a while. You can see it in pictures from 100 years ago. But the glacier's lightning-fast retreat changed everything. Between 2009 and 2015, the slope moved an incredible 600 feet closer to the water. In May 2020, a group of scientists were so alarmed they published an open letter. They had analyzed satellite pictures and found the landslide was not only huge, holding 500 million cubic meters of rock, but it was creeping, which is a slow movement that often happens right before a total collapse. A collapse this big, they warned, would be 16 times larger than the one that caused the mega tsunami at Lituya Bay. If this thing lets go, it would trigger a tsunami that could destroy nearby parts of Prince William Sound and send a massive wave hurtling toward the community of Whittier, a critical port city, in just 20 minutes. The secret was out. Berry Arm was a clear and present danger, and it was time for an emergency scientific response. To understand this slow-motion emergency, scientists had to get a closer look. A multi-agency task force was formed, bringing together the U.S. Geological Survey, the National Tsunami Warning Center, and Alaska's top geologists. Their mission: to cover this unstable mountain with every piece of tech they had to figure out exactly how it was falling apart. The main problem is something geologists call de-buttressing. Think about it like this. If you lean against a wall, you're stable. But if someone suddenly pulls that wall away, you fall. For thousands of years, the Berry Glacier was that wall, holding the mountainside in place. Now, thanks to a warming climate, that wall is gone. The mountain is fighting a losing battle with gravity. To track the fight, scientists unleashed an arsenal of high-tech gear. They installed seismometers to listen for the tiniest rumbles that could signal movement. They set up ground-based radar that can measure the slope shifting by just millimeters. And way up in space, satellites use a technique called INSAR to map the entire landslide, creating a crazy detailed picture of which parts are moving the fastest. But to really know how big the tsunami could be, they had to see what was happening underwater. The floor of the fjord was a total mystery. It had been covered by the glacier for centuries. So, in the fall of 2020, the National Oceanic and Atmospheric Administration, NOAA, sent a ship to map the bottom of the ocean here for the first time ever. Using high-resolution sonar, they built the first 3D maps of the seafloor. These maps were the key. They showed not just the underwater part of the landslide, but gave scientists the data they needed to model how a collapse would create a wave, and where that wave would go. Every piece of data was another piece in a terrifying puzzle. The satellite info confirmed the entire slab of rock was warping, with some spots moving faster than others. For a while, the seismometers were quiet, but then in 2021, they recorded a major rockfall, a clear sign the slope was unstable. And laser scans showed that between 2009 and 2015, the slope had slumped down dramatically. Even though the movement has slowed down recently, the danger is still there. The latest update from August 2025 says that while a total collapse isn't likely without a trigger, smaller collapses are still a big threat. And what kind of trigger? A major earthquake. This is Alaska we're talking about, one of the most seismically active places on Earth. The 1964 Great Alaska Earthquake was a magnitude 9.2 monster that caused dozens of deadly tsunamis from landslides just like this one. So the trigger isn't a possibility, it's a probability. The data also showed something chilling on the ocean floor. The sonar maps revealed evidence that this same mountain has collapsed before, thousands of years ago. This isn't a new problem. It's an active, long-term process. And with the glacier retreating faster than ever, the situation is more dangerous than it's been in centuries. All this information streams into a central hub where scientists look for any sign of change, any speed up in movement, any weird seismic activity, any clue that the slow creep is about to become a fast collapse. This is the biggest challenge. No one can predict the exact moment a landslide will fail. The science is all about seeing the risk get bigger and giving people as much warning as possible when the data says things are about to get critical. Every day, the mountain moves, the data flows, and scientists watch and wait. With all this data from the land and the sea, scientists could finally answer the biggest question. What would actually happen if the Barry Arm landslide let go? Using powerful computer models, researchers started running the what-if scenarios. They plugged in the landslide's size, the mountain's slope, and the brand new maps of the fjord floor. The first simulations in 2020 were scary, showing a wave up to 30 feet high could hit Whittier. But as they got better data, the models got more terrifying. A 2021 report laid out 4 possibilities. The absolute worst-case scenario, a fast, total collapse of the whole landslide, would generate a wave over 650 feet high right next to the slide. From that chaos, a monster tsunami would spread out. The fjord's narrow shape would act like a funnel, concentrating all the wave's energy. The models predict a wave up to 100 feet high in the main channel of Barry Arm, moving at incredible speeds. Just 20 minutes after the landslide, the first waves would smash into Whittier, while later models suggest the wave would be about 7 feet high right offshore. The massive volume of water and crazy currents would still be enough to destroy the port, flood the town, and threaten anyone near the coast. Other communities across Prince William Sound would also get hit with smaller but still dangerous waves. These aren't just numbers. They are a simulated reality. These models give emergency managers maps showing exactly what areas would be flooded. They turn a vague threat into a concrete action plan. Seeing the simulated wave wash over familiar places is a stark digital warning of what's at stake. The simulations prove that while Lituya Bay was history, a similar event could happen again, this time with a modern town right in the crosshairs. The science is one thing, but this story is really about the people living and working in the shadow of this threat. Prince William Sound isn't empty. It's a center for commercial fishing, a world-famous tourist spot, and a vital hub for shipping fuel and freight through the port of Whittier. A tsunami here would be devastating for the economy and for human lives. Because of this, towns like Whittier are tsunami-ready. They have evacuation routes, public education, and sirens ready to blast a warning. But the Barry Arm landslide presents a unique, terrifying problem: time. For a tsunami from a faraway earthquake, you might have hours of warning. For this one, the warning shrinks from hours to just minutes. From the moment the landslide starts, Whittier has about 20 minutes until the first wave hits. There is no time to wait for an official signal. The natural warnings, the ground shaking from an earthquake or the deafening roar of a landslide, might be the only alert people get. Officials are clear: you have to self-evacuate. Don't wait for a siren. If you feel a quake or hear that roar, you run to high ground immediately. The urgency has led to new inventions. Scientists are developing a new detection system using the state's earthquake sensors. They've created an algorithm that can specifically identify the seismic waves from a giant landslide and tell them apart from a normal earthquake. The goal is to get a reliable warning out in just minutes, shaving precious time off the response. It's a race against time, using technology to give people a chance against a wave that moves faster than anyone can run. And these events are not rare. Just in August 2025, a landslide in Tracy Arm, another Alaskan fjord, set off a tsunami. Fortunately, no one was hurt, but it was another reminder that this is an active, ongoing hazard in a changing Alaska. The fate of the mountain above Barry Arm is still a mystery. For now, it's holding on. The latest reports say it's deforming slowly, with no sign of an immediate catastrophic collapse. But it is being watched 24/7 by scientists, throwing every tool they have at the problem. This whole situation is a massive case study in the consequences of a changing climate. A melting glacier, caused by a warming planet, has woken up a sleeping giant in this mountain, putting an entire region on high alert. It proves that everything on our planet is connected, and a change in one place can trigger something powerful and unexpected somewhere else. From the historic, terrifying wave at Lituya Bay to the high-tech, round-the-clock surveillance at Barry Arm, Alaska's fjords tell a story of incredible power and constant change. Those pale scars on the mountains aren't just from the past, they are warnings for our future. They remind us that the ground beneath our feet is not always as stable as we think. The clock is ticking in Barry Arm, and it's a sound we all need to hear.